So, if you're comfortable simplifying like a square root with a number under it, a composite number, we're going to just expand on that and simplify some more complicated radical terms. So, in addition to simplifying square roots, we can also simplify cube roots, fourth roots, fifth roots, etc., remembering, right, that the square root of 25 was 5 because 25 is just, two fives underneath. 343 is also a number that we can break up using its prime factorization. And when we test out some primes, we'll find that this is 7 times 49. 49 is 7 times 7. So 343 can really be written as 7 times 7 times 7. Now, if I have 3 of the same number under my cube root, remember I only needed 2 for a square root. But now for a cube root, I need a number that multiplies with itself 3 times. So if I have that same number 3 times, that can come right out to the front. So here I've got to the 5th root of 32. So I'm going to use my prime factorization of 32, break this up as much as I can. When I do that, I'm going to see that I have 1, 2, 3, 4, 5 2's multiplied together. So this is really 2 to the 5th. Taking the 5th root is going to undo the 5th power, so this is just 2. Let's do like a slightly more complicated one though. Let's say I had the cube root of 24. When I break up 24 into its prime factorization, and I get 2 and 2 and 2 and 3, I can take out 1, 2, but that cube root of 3 is still underneath there, right? And similarly, if I had a cube root of 48, and that turned into the cube root of 2 times 2 times 2 times 2 times 3, I can take out 1, 2, that's this group of 3, will cancel into 1, 2 on the outside, right? The cube root of 8 is 2. This 2 can't come out though, still stuck under there. So then I leave my cube root of 6 underneath. So don't limit yourself to square roots, you can do so much more. And let's do a quick review, or maybe learn for the first time, of rational exponents. What that means is I have a fraction in this exponent. So x to the 1/2 power, we may or may not remember, is just another way of writing square root of x, right? X to the 1/2 and x squared undo each other to be just back at x. So x to the 1/3 power is just the cube root of x, and those kind of can continue in that pattern. If we remember our negative exponent rules, -1 just means the reciprocal. We're going to put x in the denominator. We have 1 over x. We can also have like a combo of these, right? So x to the -2 means I have x squared, and that whole thing is getting flipped, 1 over x squared. And x to the -1/2 would mean I have the square root of x, and that whole thing is getting flipped. So you can have a negative and have it be a fraction, a whole number, any of those. So here's just the rule that is a good one to remember. I'm going to write it again here in case that typed fraction is messing with your brain. If you have a fractional exponent, the number on the bottom, the denominator, is your root. That is the index of the root. And the number on top in the numerator, that is your exponent on x, or whatever you have, in the radicand. We are going to practice rewriting this. X to the 5/2 power really means x to the 5th, whole thing we're taking the square root. Now, That, we just translated that to like writing it with a root instead of writing it with a rational exponent. But there's more we can do here. So, just like how we could take square root of 48 and take out perfect squares and move them out, we're going to do the same thing here. We're going to take out any perfect squares we have. So, x to the fifth. Well, x squared is a perfect square. And I'd say there's another perfect square. And using my rules of exponents, since these bases are being multiplied, I add the powers up to 5. All right. The square root of x squared is x. The square root of x squared is x. And then we have a little 1 left over. That guy's still under the root. X squared times x. Okay, x to the negative 5/2. So remember, this is just 1 over x to the 5/2, which means it's 1 over the square root of x to the fifth. And then we would do that exact same simplifying and say, well, the square root of x to the fourth is just x squared, so I have 1 over x squared root x. Okay, x to the 5/3. We've got x to the fifth inside. We're taking the cube root this time. So I can only take out something if it's a perfect cube. Just to be annoying, I'm going to write out all 5 of my x's this time. Remember, I can only take out something if it's in a group of 3. So I have 3 x's here. That means that's an x cubed. Cube root of x cubed is just x. I can bring that to the outside. The cube root of x squared, though, is not anything particularly nice, so I'm just going to leave that as it is. Now this guy's already written in our root style instead of the fractional exponent style. Let's put it into a fractional exponent, though, instead of going the other way. So this is the same as x to the 18 divided by 3. And now you'll see why this was a great idea. What is 18 divided by 3? It is just 6, and we're done. So one last time, we've got coefficients now as well, though. So x, the square root of x to the fifth, we've done twice now, I believe, right? We had x squared on the x outside with x left on the inside. Just as a reminder, that's because we had 2 little x squareds and an x. Each of these brought 1 x out from under the root. Here I've got square root of 4, square root of x squared. Those are both perfect squares, so this is 2 times x. We're allowed to do that breaking up because everything was multiplying. Can't do that if there's adding and subtracting. How about here, square root of 12x cubed? I'm going to rewrite some of these. Let's make 12 into 4 times 3. You'll notice I picked 4 times 3 instead of 2 times 6 because 4 is a perfect square. And then x cubed, I'm going to turn that into an x squared times another x. All right, here's a perfect square. Bring the solution out. Here's a perfect square. Bring that solution out. And underneath, I still have 3x. Now, reminder, just like we had in that cube root of x to the 18th, you can just shortcut some of these. This is the same as 54 over 2, because that square root is a 1/2 power. You can just do that math. That'll be a lot faster than writing out all of those x squareds. Here we've got the square root of 81. If we know that, that's just 9. And then square root of x to the 6th divided by 2. Well, that's just x cubed. Now, what have we got in here? 40. I want to use that 4, I think. 4 times 10. An x squared and an x. A y squared and a y squared and a y. All right, all my perfect squares are coming out. We've got a 2. We've got an x. We've got a y. We've got another y. And left underneath is 10xy. To finish that up nicely, I would make that into a y squared. And we're done.